Hello everyone, welcome to the third lecture for Introduction to Data Science. The outlines of this lecture is explore, exploratory data analysis, visualize EDA, single versus multiple variable analysis, and number 4, normal distribution analysis. At the end of this lecture, the students should be able to explore the concept of exploratory data analysis, visualize EDA using appropriate visualization format, explain the concept of single versus multiple variable analysis, demonstrates the competency using the data science tools for EDA. Exploratory data analysis is an approach or philosophy used by data scientists to analyze and investigate data sets and summarize their main characteristics. Actually, EDA is a critical process in the data analysis where analysts use visual and statistical technique to understand the main characteristic pattern and relationship between data sets. So with this tool, the data analysis will understand the relation and the character and the pattern of the data set. So for example, you have a data set, you want to understand the pattern, what is going on, we use this tool and we use this approach. It uh, it helps determine how best manipulate data source to get answers you need, making it easier for data scientists. Okay, for example, to maximize insight into the data sets, to discover the pattern if we want to understand the pattern, test the hypothesis, and extract important variables or use or check the underlying assumptions and etc. Use DEA to ensure the results they produce are variables and applicable to any desired business outcomes and goals. There are some examples of specific statistical function and techniques you can perform with EDA tools. These are some examples that um, we can use these tools for EDA, which has clustering and dimension reduction technique, univariable univariate visualization, k-means cluster, predictive model like linear regression, like neural network. Okay, ignore these two, no need that these two page, we go through page number 5. Okay, data visualization is a process of putting data in the chart graph as we had in our Friday on lab 2 that we went through to the chart graph. We use Python for making our data visualize as a graph chart, bar chart, pie chart. That it helps inform analysis and interpretations. Okay, used to communicate results to make the stakeholders needs. Multiple visuals will likely to be needed to understand the larger change process and inform data use. Okay, that this is the features of visualize EDA. Okay. Okay, it include the common. There are some common data visualization formats that we talk about: the bar chart, histogram, line chart, bar chart, heat map, scatter graphs. Some of them we discuss on the Friday, right? You can see there's some examples of visual EDA: bar chart, line chart. You can see pie chart, right? Okay, simple versus multiple variables analysis. Single variables or univariate, one variate at a time. So we discuss about one variable at a time. When you begin to look at your data, it's important to learn about each variable before looking at how the variable interact with each other. So univariate graph let you visualize each variables individually. So if you want to consider each variable individually, we use univariate graph. We can use histograms for continuous variables and bar charts for categorical variables. Okay, so we know that there are two type of variables, but as continuous and discrete variables. Continuous is continuously like 1.2, 1.3, 1.4. This right. And categorical variables like quantitative. The qualitative means includes the for example type of car models, for example car companies, Proton, Toyota. They are categorical variables. They are names, color of something, for example. Continuous is variables like a weight, for example. Weight is continuous. So weight cannot be, for example, 10 kilogram, 11 kilogram. We have 10.1, we have 10.2. Between 11 and 10, we have many variables. So it is continuous. We discussed the type of data. I can share with you that we have two types of data variables, which is qualitative or numerical, and quantitative or categorical. So that one deals with description, qualitative, and quantitative deals with number. If we have quantitative, we can apply the uh, mathematics on it. For example, we can divide it, we can multiply to something, we can apply in the function. So data which is quantitative deals with the number, and we can measure it like length, height, area, value. But qualitative data deals with description. The data can be observed but cannot be measured, like color, okay, like texture, smell, okay. And quantitative data variables are divided to discrete variables that can be assumed only infinite of countable number of variables. One, like 1, 2, 3, not decimal number. Okay, we have like a person, number of students. For example, we don't have 2.5 students. We have 3 students, 2 students, 4 students. Okay, it's not decimal number. Continuous number is like a variable that can take on many different variables in theory. Any value between the lowest and highest points on the measurable scales, like centigrade. So, 27.8 Celsius. Height is 176.8 centimeter. Okay, so this kind of data are continuous and type of quantitative. So this is the comparison between single variables analysis, which is in histogram there is no gap, and in the bar chart there is gaps. Okay, because bar chart is a categories like January, February, March, April, we can put a gap. But in the histogram, which is for example, it can be for example the range. So we have something between 4 to 8, 8 to 10. There is no 7.9 gap between 7.9 and 8. It's continuously they are related to each other. So there is no gap. So in that case, we use histogram. We don't use bar chart. Bar chart for categories. For example, the cells of the rainfall, for example, in January, February, March, April, and May. Okay. Okay. For multi-variables, two or more variables. Okay. In multivariable, we have two or more variables. Multiple variable graph let you visualize the relations and the pattern between two or more variables. As we can use the scatter plot to compare two continuous variables, bubble plot, specialized scatter plot that use color and bubble size to represent up to 5 variables at once. For example, graph builder to create a change of a graph interactively, side by side, box plot, overlay plot. We can use this kind of plots for visualizing the multiple variables. Okay, you can see some of them. This is a scatter bubble plot. This is the graph builder, and this is the, I think, box plot, which is side to side box plot. Yes, this one is a box plot on the right side top on page 7. Okay, visualizing univariate continuous data. Univariate data visualization plus help us comprehend the enumerative properties. Comprehend means understand. The enumerative means several properties such as descriptive summary of the particular data variables. These plots help in understanding the location, position of the observation in the data variables in distribution and person. Okay, univariate plots are in the two types. Enumerative plots shows every observation in the data. Summary plots gives more concise descriptive of the location, description, and distribution of the variables. So you can see the example of a scatter plot and the line plot. Okay, these are the examples of enumerative data. Plot. Okay, so show every observation in the data. So another example is a strip plot and a swarm plot. So you can see all the detail, all the observation, show every observation in the. Okay, these are the example for summary plot, that histogram of arrivals, histogram plot that it shows the description of the location, dispersion. Okay, and some other example you can see on page 10. Okay, properties of the normal distribution. All symmetric. If the normal distribution, if our graph have a normal distribution, you can see the symmetric data. So there is no skewed in the date distribution. Okay, the mean, median, and the mode are all equal. 50% of the population is less than the mean, and 50% is greater than the mean. It's the average. 50% is of population are the more than the average. 50% are less than the average, greater than the average. So it means that we will have the normal distribution in our data. So if we have less skewed graph, negatively skewed distribution, mean to the left of the median. Okay, you can see the mode, median, and model. Okay, mode, median, and model. So in the right, the mean is the right of the median, and the left is skewed is the left side of the median. Okay, we discussed about the mean, mode, and median here, right? So let's see what is meaning of them. So mean is the average, which is the summation of each element divided to number of them. The median is the middle value in the order data set. So it means if we have our data set like 3, 5, 7, 8 from the lowest to the biggest is ordered, and the middle one is our median. If there is an odd number of the value, is the median is in the center. If there is an even number of value, it's the average of the two middle value. For example, if here is even 1, 2, 3, 4, we have even one. So these two are the middle, right? 5 and 7. So the average of them is 6. So 6 is our median. Mode is the most frequent occurring value in the database. There can be more than one mode or no mode if no value repeated. For example, here 3, 3, 5, 7, 10. The mode is 3 because 3 repeated for twice. The others only once. Okay. Okay. So if in this graph says that if the left is skewed means the mean is the left side of the median, and the right means right of the median. Okay. How to check the normality of the database? So in the histogram also is the same. If you make a line between the center of each bar, you can see it's normal. Okay, so it's code is in the middle, but this is the left side. Okay, and the other one is the right is code. Okay. Scientific test, parametric versus non-parametric test. Parametric tests commonly used for performing a statistical hypothesis test. Several conditions for validity must be met so that the result of the parametric test is readable. For example, a student's test for two independent samples is reliable only if each sample followed a normal distribution and if sample variants are homogeneous. Parameters is analysis to access group mean. Non-parametric test is distribution free test. Do not rely on the distribution. No need to have a normal distribution. Thus, that can be applied even if the parametric conditions for variability are not met. Non-parametric analysis to assess group medians. So for the static analysis for t-test, for example, we can use t-test for the Uh, okay, the parametric test rely on the distribution of the data, like, and we can use the t-test, ANOVA test, and this kind of test to for statistical analysis. But non-parametric data not, does not rely on the distribution. So doesn't matter the distribution, as we discuss further here, doesn't matter. Okay, so for parametric test we can use sample t-test, ANOVA test, and fractional DOE with a factor and a blocking variable. For non-parametric test we can use sample sign, sample Wilcoxon, Vinti test, and you can see the different tests that we can apply for parametric and non-parametric tests. Different functions for data analysis. There are four type of uh, EDA. Univariate, non-graphical. This simplest form of data analysis, where the data being analyzed consists of just one variable. Since there is a single variable, it doesn't deal with causes or relationship. The main purpose of univariate analysis is to describe the data and find patterns that exist within it. So we go through the data, which is only one variable, and we go through to find a pattern. Is increasing, pattern means it's increasing, decreasing, and the distribution of the data. Univariate graphical. Non-graphical methods, the previous one, does not provide a full picture of the data. So this is a disadvantage of non-graphical one. So graphical methods are therefore, so we need graphical methods. Why? Because non-graphical methods doesn't provide a full picture of the data. Common type of univariate graphic includes a stem and leaf plot. Okay, we show all the data variables and shape of distribution. Histogram, a bar plot, which bar represent frequently. Box plot. Okay, this all univariate graphical type of univariate graphical. So we have multivariate. So we have univariate and multivariate. For univariate we have non-graphical and graphical. For multivariate we have non-graphical and graphical. Multivariate data rise from more than one variable. Multivariate non-graphical DA techniques generally shows the relationship between two or more variables of the data through cross tabulation or statistics. So we have more than one variable and we go through the relationship between two or more variables. Multivariable graphical uses graphics to display relationship between two or more sets of data. So the difference is we use graphical method. This was use graphic is a grouped bar plot or bar chart with each group representing one level of one variables and each bar within a group representing the level of the other variables. See the types of the graphical method graphical visualization for multivariance uh, data. Okay, a scatter plot, multivariate chart, which is a graphical representation of relation between the factors and the response, run chart, bubble chart, and heat map. Okay, so these are different functions for data analyzers. Ex- Exploratory data analysis tools, which are used for DEA tools that we use, programmable and non-programmable. Programmable, we use Python as we use in our lab, and R also, RStudio. We can use RStudio for R. And there are non-programming data like Excel, like Vika, like Orange, Big ML, Microsoft Azure, ML Studio, Data Wrapper. So there are plenty of non-graphical tools. And you can see some examples here. You can go to the website. Later you can do it. Okay, lecture 3 is over. Thank you very much for your attention and see you on next week.